And we're back. So taking a look at this particular circle, I know that the radius is 2 inches. And I know that's the radius because it goes from the center out, and the diameter would go all the way across. So it wants me to find the circumference and area. Well, if you go back and you look at that formula chart, on the front side, we have our circumference and our area formulas. Now, for circumference, you probably have seen both of these before. So pi d means pi times the diameter, or 2 pi r, so 2 times the radius. And that's because the diameter is 2 radii, so like 2 times the radius is the diameter. So it does not matter which formula you use. In this particular case, I'm going to use circumference as 2 pi r, and that's because I have the radius. So the radius is 2, so 2 pi 2. Well, if we leave it in terms of pi, that means that we're just going to multiply that 2 and 2. So in terms of pi, that would make the circumference 4 pi, and the units would just be inches because circumference is like perimeter. Now, if you wanted to actually find out what is 4 pi, then you would go to the calculator, use 4, press that pi key. Remember, the pi key is right above the caret key. It looks like that. So second that key. And it should give you 12.566. We would say 12.57 inches. Now, if the problem doesn't clarify, leave it in terms of pi. That's a lot easier, but if it says round it or to the nearest whatever, then it wants you to actually type pi into the calculator. So it's kind of the opposite of what you think, because in terms of pi means that you don't actually touch the pi key, but whenever we round it, we do. So in terms of pi means we don't touch the pi key, we just do everything but pi. So area, if you go back and you look at that formula chart, the area one's on there too. So area is pi r squared. So if area is pi r squared, and the radius is 2, that would be pi times 2 squared. Well, 2 squared is just 2 times 2, which would make that 4 pi. But area would be inches squared. And then if it wanted it as a decimal, we already found out that 4 pi would be 12.7 inches squared. So that's it. And you probably have seen circumference and area before, so hopefully that's nothing too new. But sometimes you have to work backwards. So for this particular problem, it says the area of a circle is 106 square centimeters. Find the diameter to the nearest centimeter. So how we find area of a circle, we have that formula, was just pi r squared. But this problem is different because it tells us the area. So it tells us what A is. So A is, the area is 106 equals pi r squared. And now I'm going to go backwards. So I don't see a pi with area, it's just 106, which means the first thing that I'm going to do is divide out pi. I'm going backwards, so typically like we multiplied by pi, now I'm going to divide by pi. And so if I do 106 divided by pi in the calculator, that tells me that it's 33.7408, so I'm going to say 0.741. Equals, I still have the radius squared. So I took out the pi, so 106 divided by pi, and now I have the radius squared, which I just want the radius. So remember that we can undo a squared with a square root. So if I take the square root of that number, then I get that the radius is about 5.8. So the radius is about 5.8, 5.81, depending on how you round it. Now, this particular problem didn't say find the radius, it said find the diameter to the nearest centimeter. Well, if the radius is 5.8 and that's half, then just multiply it by 2 and that's going to tell you what the diameter is. So 5.8 times 2 would just be 11.6. And if it says round to the nearest centimeter, I'm going to go all the way up and say that the diameter is just 12 centimeters. So if you can go forwards, you can go backwards. We're just undoing the steps that we did in that previous problem. So instead of multiplying by pi, we divided by pi and then we square root. That was it. Now if we have the circumference, now I'm going to use the circumference formula. So the circumference is 48 pi, find r. So my circumference formula, I'm going to use 2 pi r because the question asked me for the radius. So that's why I'm going to use that particular one. And they told me the circumference is 48 pi. So there's your C. So if the circumference, or C, is 48 pi equals 2 pi r, now I'm going to go backwards. So the first thing that I'm going to do is divide by pi. So I'm going to get rid of pi by dividing by pi. And this particular one had a pi in it. So it makes it real simple. I can just cross them out. And now I have that 48 equals 2r. So if 48 equals 2r, divide both sides by 2. That would make the radius, 48 divided by 2 is just 24 inches. And that's it. So as we continue to take a look at circles, we are going to be doing some solving, and part of that is, can you find the area? Can you find the circumference? And we'll be doing different things with it. But it also helps if you know your vocabulary. So if we take a look, which one of these, so pick up here from your word bank, and I'm going to go a little bit backwards. So my first word is adjacent arcs. So I'm going to look down here for a picture. Remember that adjacent means that they touch. So I'm talking about two arcs that are adjacent, two arcs that touch. And the only one that has two arcs that touch, that's AB and BC. There's your adjacent arcs. Now, it doesn't really matter what order we go in, because if we look back at this first one, if I'm talking about arc AB, well, that's not an angle. It's not a major arc because it doesn't take up more than half. But if I take a look, what is arc AB? If that's half of a circle, well, there's your semicircle right there. And if I take a look at this one underneath it, well, we've talked about that before. So it's talking about the angle from the center. Well, there's our central angle. And this next one, hopefully you know what that is. Sometimes it looks like that in a circle. Sometimes it looks like that in a circle. Sometimes it looks like that. But AB is just talking about, if we take a look up there, AB is talking about the diameter. And since we just did diameter, I want you to see if you can find out which one is the radius. Which one would be the radius? That'd be this last one. Okay, and then I see right here arc ABC, that's 3 letters. So asking yourself, we talked about that earlier, would that be a minor, that's an arc, but would it be a minor arc if it's 3 letters? Well, it would have to be a major arc. Which means I only have 2 left, and that's concentric circles and circumference. Well, circumference is the perimeter of a circle, so that's that one where it's bolded. Which makes the last one our concentric circles. Concentric circles are just circles with the same center. So it's kind of in that name right there, like concentric, they all have the same center. Concentric circles, just circles with the same center. That's it. Okay, now some of the new words that we talked about, some of those you'd seen before, diameter, radius, you were able to figure some of them out. But we also talked about chords, secants, and tangents. So taking a look down here, if I ask you what AD is, well, AD is a chord, but a very special chord. That would just be the diameter. But if I asked you what EG is, well, EG is not the diameter. Think, what was the name of the word for the line or the segment or the ray that just tapped the circle one time? So it just intersected it one time. And that was tangent. And on that tangent, if I asked you what point F is, remember that would just be your point of tangency. So like where EG taps the circle at F, that's your point of tangency. The next one says FB. Well, if I just connect F to B, it doesn't have any arrows on top. So FB, just like that, that would just be another chord. It's not the diameter. It doesn't pass through the center. If I actually draw it, it doesn't pass through the center, but it does stop. So that would make that a chord. Now, if I changed it to this, would that change things if I made it a line so now it goes through the circle? And the answer is yes. If I see arrows on the top, that wouldn't be a chord anymore. That would be our secant. And then I'm going to give you a minute to see if you can do those last 3 on your own. And then we'll be right back to check. Hopefully you're able to get those. That CD was a radius. HB was another chord, different from HB with arrows. If they had written it like that, that would be a secant. And then FE, well, the closest one to FE is another tangent. FE is not really it's not a radius, it's not a diameter, it's not inside the circle, so it can't be a chord or secant, therefore it just has to be a tangent. And that's it for vocabulary. Your practice is going to have some vocab questions and some questions like this with the solving. Remember that all the way around is 360 and that half of a circle is 180. Good luck, and we'll see you next time.